Hi everyone, welcome to the sixth episode of XCI ByteCast, a series of bite-sized tips and tricks that can be implemented into any of your projects. In this video, we're going to implement a caching for network requests. This is very suitable if your app doesn't need to display data that changes frequently, such as news, recent stock prices, transaction histories, image, and etc. It provides several benefits such as first, faster load times. Cache data reduce the need for repeated network requests, making data retrieval almost instant, especially for frequently accessed content. Second, offline access. Access previously loaded data when the users are offline or have a poor internet connection. Third, less server loads. Reduce the number of requests sent to the server, which can ease the backend system, especially during the high traffic periods. And last, reduce network data usage and power consumption. By minimizing repeated network requests, caching helps in conserving mobile data usage, which is beneficial for users with limited cellular data as well as battery life. First, let me show you how this works in action. So here I have a simple SwiftUI app that fetch posts from the network remote API, then display it in a list. So here's the list. Notice in the console log that the first time the app tries to get the cache, it doesn't exist for this particular URL. Okay, and basically it's going to kick a Swift task to fetch the data from the network. Here, set in flight task cache, and it's fetching the data. And finally, it set the cache response in the network cache and display it in a list in here. Okay, so here let me try to close this window. Okay, and open a new window. Okay, so if you see here, so when it loads the new window, basically it's going to just get the cache, get the post from the cache. It doesn't need to make any new network request again. Okay, so this is the cache that we are going to build. So if I open multiple window like this, right? So there is no need to make a new API request for each of these window. It will just load the post from the cache. Okay, so this is the final implementation that we are going to build for this network cache video. Okay, so this is built using the generic cache in the ByteCast 5 that I have mentioned before, and it also supports the additional expiration timestamp support and uses the Apple in-memory NSCache under the hood. So if you want to learn on how to build this cache, I encourage you to watch ByteCast 5 if you haven't. Link to that video is provided at the description below. Okay, so without further ado, let's begin to implement this. Let me close this. Okay, so let me open the starter project in here and let me guide you through the starter project. So first, let's begin from the model. Here we have the post.swift file. So this is the post and the post response model. It represents the JSON that we will fetch from dummy JSON endpoint. Okay, and the next one is this view state. Okay, so it represents individual UI states such as idle, loading, success, and error. And next is the store. So this is the observable class used by the main view. It stores the states and provide the logic to fetch the post from the remote endpoint. Okay, and let's go to the post list view. So this is the main SwiftUI view to display the UI of the post inside a list. It's going to be based on the view state from the store. It handles various states such as here, if you see in the overlay view, such as loading, error, and also empty data. And if you see in here, it uses SwiftUI task modifier to handle the data fetch lifecycle from the store. If you want to learn about this SwiftUI task lifecycle, you can watch ByteCast 4 from the link at the description below. Okay, so now let's begin the implementation. So just create a new Swift file, give it a name of network cache. Okay, and basically first let's create an enum to represent the fetch phase. Okay, give the name of enum fetch phase. So it's going to accept a generic for the data type. So there are two cases. The first one is the fetching. Okay, so this is going to be a Swift task containing the generic as well as the error. Okay, so we will cache the Swift task containing the in-flight request for the network given the URL. This will handle the case where there are two views that want to access the same cache, but the first view is still fetching the data. So basically the second one will just use the cache task, avoiding duplicate network requests for the same URL resource. So after the first one completes, it's going to cache the response. So the subsequent access will just use the cache response. We will implement that later. Okay, the second case is the cached. So this is the response containing the generic. Okay, so that's it for the fetch phase enum. Now let's declare a Swift actor, give the name of network cache that accepts generic that conforms to decodable protocol. Okay. So this actor provides thread safety in the new Swift concurrency, and all the resources, the method will be accessed sequentially and avoiding the rest condition. Okay. The first thing that we are going to do is we are going to declare the cache. Okay, so this is the cache that we have implemented in ByteCast 5. Okay, let me just show you. So this is the cache and it uses the NSCache under the hood. Okay, so we're going to declare this cache and the value will be fetch state. Okay, fetch phase with the fee. Okay, and next let's declare our decoder, which is JSON decoder, and let's just initialize the default value. Okay, default JSON decoder, and I explicitly make this as a var so it can be updated if the client want to use their own JSON decoder. Okay, also the URL session, this one will be I'm just going to initialize it with the shared URL session. And now let's create a func value from your request. Okay, your request async. So this is going to run in async context. Okay, inside this actor, and return an optional fee. The first thing that we are going to do is we are going to use guard let URL string. We are going to get the URL request URL. It's optional. If it is nil, then we'll just throw invalid URL. Okay. And next, let's declare a Swift task. Let task. So it's going to be task with the value of v, and it's going to be error for the error value, generic error. And here we simply declare this tuple that data and response, and then use try await self URL session data for URL request. This returns a tuple. Okay, and here let's just use guard response. We need to cast this as HTTP URL response, and we need to check if the response is between these 2 execs. Okay, contains res.status code, else means it fails, right? Because it's not 2 execs. Here we just throw invalid response status code. So this is just a naive implementation of handling the response. You can provide your own advanced custom implementation in here to handle the response. Okay, and in here let's just declare the value and invoke self decoder. Okay, the JSON decoder, and the code we're going to use this v generic v.self from the data. Okay, and in here we're going to return the value. Okay, so that's the task that we have declared. Now after this we need to basically cache this ongoing in-flight task. Okay, it's going to fetch that asynchronously. So we are going to use the URL string as the key and then store this using the fetching case. Okay, and let's pass this task. So this means it's still being cached. URL string. Oh, I think this needs to be URL dot absolute string. Okay, so it's going to be a string, and then we are going to use that as the cache for the key. Okay, so it's being fetched. And next, let's do try catch in here. So in the cache, we just set the cache URL string as nil. Okay, so it fails to fetch the data and just throw the error. And in the do, basically, let's I think I need to add some print statement to help us debugging this. First, we're going to print in here cache set in-flight task cache for the URL string. Okay, this is just for helping us in debugging. Okay, next cache fetching data from URL string, and then let's declare the value. In here we need to use try await task.value. Okay, so we're going to await this task to be completed, and then after it completes we just need to print again cache set response cache for the URL string. And finally, this is very important, we need to invoke cached URL string with the value of this cached and pass the value. Okay, and finally we just return the value. Now let's get back above this task. So in here we need to add the logic to where we're going to actually check the cache. So here we're going to use the if-let cached. We're going to ask the cache for this URL string value. Okay, so here we're going to use switch based on the case. Okay, so in case it is fetch, basically still waiting for the response from the network request. Here we're going to just print for debugging cache loaded response cache for the URL string. And in here, this is very important, we're going to basically return try await task value. Okay, so this will basically await the same network request, it won't create any new requests. Okay, so this is very useful if there are two views that is going to access the same URL resources from the cache. Okay, the first one will make the URL request and store the task in here, and as it's still downloading the data, fetching data, the second one try to access, it's going to get this task and then await the same network request. Okay, avoiding duplicate network requests for efficiency. Okay, and after the first one completed, it's going to set the response in the cache. Okay, given the URL string. So that's the implementation for this. And for the cache scenario, it's very simple. We just print cache loaded, this is not response cache, sorry, loaded in-flight task cache for. Okay, this is the one should be loaded response cache for URL string. So it means the response is already cached and we simply just return the response. Okay, that's it. We have implemented this network request caching, handling the in-flight and the response as well. And next one, we're going to add the optional expiration timestamp support. Okay, so let's just implement this. First, let's declare the expired timestamp provider. This is going to be a closure, the provider parameter of the fee, and return the optional date. So this is optional. Okay, so it can be used to add the expiration timestamp for the cache. So if you see this closure itself will give you the response, right? So this provides the possibility to dynamically set the expiration timestamp from the value provided by backend server. Okay, so in some instance, if you want the backend to provide the timestamp, expiration timestamp, you can provide it this in your JSON response, and it can be used in here to provide the expiration timestamp date. Okay, we'll see the implementation later on the store. Okay, and after that we need to create a method to set this. So let's use set expired timestamp provider. Okay, so it's going to be a closure as well, and same to the optional date. And here we can simply set this. And one more thing, we need to update this. When we set the response cache, we need to use cache set value for key with the expired timestamp. Okay, value will be cached value for key URL string, and the expired timestamp we can get invoking this closure expired timestamp. Okay, remember it's optional, and pass the response. Okay. Okay, now it has the optional timestamp expiration support as well for this network cache. Now let's go to the store. Okay, the observable store. First, let's declare the cache as a property in here. Okay, so let's declare a let cache. It's going to be network cache, and the generic value will be the post response. Okay, and in here we need to create an initializer that upset the cache, network cache post response, and we can provide an initial value of just initializing it. And let's just set the cache. Okay, so this is the URL where I get the post using the dummy JSON service. Okay, it provides several dummy resources that you can use. Okay, so this is the one that I'm using, post. Okay, let's continue to create this method. Okay, set expiration timestamp handler. It's going to be async. Okay, because we are using the actor. So here let's check if await cache. We're going to set this only once. Okay, if await cached expired timestamp provider is nil, only in that case we're going to set this cache set expired timestamp provider. Okay, as you can see, it passed as the post response. So let's say the response contain the expired timestamp from the backend. You can return it in here. Okay, but in this case, the post response from dummy JSON doesn't provide anything. So in here we can simply return our own logic. So let's say we want to invalidate the cache like seconds by adding seconds with the value of 300 to current time. Okay, so this is like basically 5 minutes, right? Or you can also use minute with the value of 5. Okay, and if you don't want to have any expiration cache, you don't need to set this, or you can also set this return nil. Okay, now we have this. Now let's update the fetch post method to use the cache. Basically in here we need to basically remove this. We don't also need this. So in this do, basically we simply declare post response and use try await cache value from your request. Okay, and that's it. We're going to fetch it from the cache and using the cooperative cancellation to check if the task is already cancelled. And in here we can simply, so this is optional, right? So we need to use this and just provide an empty array if it is nil. Okay, that's it for this fetch post update. And one more thing that before I forget, the network cache, let's also add the invalidate cache method. Okay, in here func invalidate cache. In here simply invoke cache remove all values, and in here the store we can also add a new method func invalidate cache. Here we can simply invoke cache dot invalidate cache. Oh wait, let's make this async as well because this is an actor, right? Okay, that's it for the store update. And finally, let's go to the post list view. Okay, and in here we can simply declare several buttons. So here inside the list, I'm just going to copy and paste this to save time. So there are two buttons in here. The first button is to refresh with the cache invalidation. So when it is pressed, tap, we will call the store invalidate the cache and then refresh the task to fetch the post again from the remote. The second button is to refresh the cache without the invalidation. So it will respect the expired timestamp as well. Okay, and the next one is we need to, this task, right? We need to add this method to set the expiration timestamp handler if needed, right? Because it's going to check only if it is nil, it's going to set. And before we test this, you can also go to this entry point, which is the network cache app, and then we need to declare this cache here as a state network cache post response. And let's say if you have a multiple view that is using the same cache down the hierarchy, you can pass this from the top. Okay, in here I'm just going to initialize the store with the cache. Okay, so that's why when I open a new window, it's will going to use the same cache object. Okay, and that's it. Now let's try to run this. Okay, as you see, the cache doesn't exist. And let's test the button, refresh from the cache. Okay, so it's going to load it, the cache response. It's not going to make the API call because it's already cached. So let's say I invalidate the cache. Okay, if you see, it's purged the cache, and then it's basically going to, the cache doesn't exist, and it's going to make the new network request again and cache the response again. So this is the implementation of this network request caching for this ByteCast 6. Hope you like this video and subscribe if you haven't to the channel, and thanks for supporting me so far. And finally, let's keep on being a lifelong learner, and until the next one, goodbye.